Hello, my name is Deepak Waski Kashyap. I have chosen detecting spam comments in YouTube as my project topic.
I will begin this presentation by introducing the topic, following which we will discuss why spam is such a big issue, and then go into the motivation behind choosing this particular project. Then we will discuss some existing techniques for detecting spam. After this, we will discuss how the dataset was acquired, processed, and how the features were extracted. After this, we will look at the various machine learning models that were implemented and the accuracy they gave when validated on the test dataset. Then I will wrap it all up with a quick summary. YouTube is one of, if not the biggest video sharing platform in the world. The platform sees over 2.6 billion active users, and some stats say that it has a collective watch time of over 1 billion hours every single day. There are also some other stats which say that over 500 hours of content is uploaded to YouTube every single minute. So YouTube very clearly has tremendous amount of traffic that it sees all the time. So also YouTube boasts content on a diverse range of topics, and it has users belonging to all the different age brackets. And something at the very foundation of YouTube is, the channels that make up this particular platform. So the channels are the driving force uh, behind YouTube as a platform. And the comments feature under these videos are a great tool for people to come together and for channels to grow their own communities. So it's a great feature. But given YouTube's size, it is not surprising that there are some problems that have come up quite naturally. So one of the main problems that have come up is that of spam comments. Every single day, millions of spam messages are being posted on YouTube, which block the intended usage of the application's comment feature. In these spam comments, malicious links, which when clicked, install viruses on users' device, um, are being posted. There are also spam comments. There are reports of spam comments being used in order to lure underage users in real life. So these are all major issues that require urgent attention. So in the slide, there are examples of how common spam comments look like. So after receiving several complaints from its users, YouTube has implemented a reporting mechanism for tackling the issue of spam comments, but this has largely been insufficient to tackle the growing challenge. There are still numerous reports of pedophilic rings that are thriving uh, through the spam comments on YouTube. So it still needs urgent attention. This problem still needs urgent attention. And even otherwise, the content being spread in these spam comments are unwanted and oftentimes they're very malicious. Now let us look at some of the existing spam detection methods and see if any of them are useful to tackle the problem that we are trying to solve. So there have been techniques that have been developed to detect spam blocks. These are not too effective in detecting spam in YouTube comments, however, as they're generally more effective at spam detection when they're allowed to operate on a large body of text. So YouTube comments are often small and look quite similar to a genuine comment. There are also techniques where a list of blacklisted URLs are maintained in order to detect spam. So the effectiveness of this technique hinges on the quality of the URL list that is maintained. So even if a similar approach was implemented, this is not a very practical solution to solve the problem at hand, especially considering the scale at which YouTube is operating. There are also techniques which have been introduced that detect spam by studying the previous posts made by the user and also the activity of their followers. So this is something similar to what Twitter has implemented, where Twitter sees the past 100 posts of the user and also sees the followers of that particular user before determining whether a particular post is spam or whether the account is a spam account. So these are not very useful again for detecting YouTube spam comments as the ecosystem is completely different and YouTube does not store user activity and information in the same way that Twitter does. There have also been spam detection techniques developed for emails. Uh, they have been there for a very long time. But these are not, again, very effective because most of the email spams are sent by bots, and in YouTube, most of the spam messages are actually sent by real people. So these algorithms don't really solve the issue. The same thing can be said about the techniques which detect the spam by using sentiment analysis. Also, these techniques are not really feasible at the scale at which YouTube operates. So that is also there. So lastly, the spam detection technique implemented on TED videos identifies the context of the comment and checks how much it deviates from the context of the video. So on YouTube, however, it's not a very practical technique which can be implemented as there are billions of videos on countless topics. So it's not really the most practical approach, practical technique that can be implemented on YouTube. So very clearly, there is a space and there's a problem that still needs more solving. So now let us look at the key steps involved in the implementation of the project. These include acquiring the dataset, cleaning and processing the dataset, feature extraction, and training and testing the machine learning models. Now let us look at each stage in detail. The dataset used in this project is from the UCI machine learning repository. It is comprised of 5 CSV files, one for each of the 5 videos the comments were taken from. So these comments were taken from 5 of the top 10 most viewed videos from the year 2015. So in total, the entire dataset contains 1,956 comments. The files have columns for comment ID, the author of the comment, the date on which the comment was posted, the actual content of the comment, and also a class column. So each comment additionally in the dataset is marked manually, um, whether it is a spam or not. So if it is marked as 1, then it's a spam, and if it is marked as 0, it's not a spam. So the cleaning dataset and processing data stage has 3 main steps. Step 1 involves removing non-essential data columns from the dataset. For example, the column author, date, comment ID is of little use to detect if a comment is spam or not. So these columns are dropped. In step 2, every character in the comment is converted to lowercase, and any special characters, numbers, punctuations are all removed. So these characters again won't help directly to detect if a comment is spam or not, so they are dropped. Then in step 3, the clean dataset is divided into training and testing dataset. To perform this, the train test function from the scikit library is employed. So the dataset has been split in a 80-20 split, that is 80% for training dataset and 20% for testing dataset. So this leaves 1,563 comments for training each model and 393 comments for validating the model and figuring out their accuracy. So in the extraction stage, there are 3 main steps. The first step, the bag of words technique is employed to split each word in the comment as token, and the number of occurrences of each word throughout the dataset is counted. Now, here duplicate entries for the repeated words are not considered in the bag of words technique. So the end result, it will only have distinct words. In step 2, the count vectorizer function from the scikit library is employed to vectorize the comments based on the counts and tokens found in the previous stage. In this stage, the count vectorizer function also removes stop words like and the. In step 3, the TF-IDF function of the scikit library is employed to reweigh the terms and extract the features. So now let us consider the following example in order to get a better understanding of how the data is cleaned and processed, and the features extracted, of course. So in the slide, we can see 3 comments. So in this comment set, we can see 3 comments. And we can see that several words in these are repeated. For example, hello is repeated in all the 3 comments. The first step is to remove punctuations and convert all characters to lowercase and remove numbers and other special characters. Once this is done, the bag of words technique is employed, and every comment, the words are tokenized. So, so this is something it will look like. So you'd have hello, although it's repeated 3 times, it's only there once in the final set. So hello, who are you, how, click this, all the different words are in the set. The next is the counting phase, where the count of each token across the dataset is taken, as shown in the table on the slide. For example, the word hello repeated in all the 3 comments, so its frequency is 3 in the table as it's evident. So next in the count vectorizer stage, each comment is vectorized. Um, you can see that there is an element for each distinct token, which was identified earlier. So whichever token is present in the comment is marked with 1. And if the comment does not have a particular token, then the spot is filled with a 0. So for example, hello, who are you? So this was essentially the first comment. So all the words that are present in this particular comment is marked with 1. And if a particular word is not present in this particular comment, then it's marked with a 0, as it's evident here. Now, in this stage, the weights are also assigned to each of the word. It is important to note that just because a word has repeated more number of times in the dataset, it does not mean that it automatically has a higher affinity to be a spam word. If you look at this particular instance, for example, hello is repeated 3 times in the comment set that we see. But that does not mean that hello has a higher affinity to be a spam word. In the same example, if you consider, for example, like click and link, these words are repeated or they're only present once, but they might have a higher affinity towards being a spam word. So, in order to tackle this issue of less meaningful information overshadowing more meaningful information, the term frequency inverse document frequency function provided by the scikit library has been used. So in this function, essentially, if the word has been repeated more times, the IDF score of the word will be less, which means that if the word is repeated more number of times in a document, it will have less meaning attached to it. Similarly, words that are not repeated often will have a higher IDF score attached to them. The idea being that less repeated words add more meaning while detecting spam words. The formula for finding the IDF value and the TF IDF value is on the screen in the slides, that is. Now let us look at the various machine learning models that have been implemented in this project. They are logistic regression, random forest classifier, support vector machine, naive Bayes method, and multi-layer perceptron. Now let us look at each of them in detail. So logistic regression is a machine learning model which is often used when dependent variables are categorical. This means to say, for example, if we have a question, is a comment spam or not? So this is a yes or no kind of question, like you have true or false. So in these kind of instances, logistic regression can be used. In this project, I have used the logistic regression model provided by the scikit library. The tuning parameters were configured as shown in the slide. The limited memory objective function, that is LBFGS, is being used as a solver algorithm. So this helps to find the minimum for the objective function, and using the objective function's value and the gradient, it helps to achieve a better fit. Also, the value of C has been assigned to 1 and penalty is L2. Here C is the inverse regularization strength and L2 is the regularization. So regularization is critical because it helps to improve the performance of the model on data which it has not already seen. So this is done by adding penalties to higher values, and essentially regularization prevents overfitting and reduces the error of the model. So also logistic regression model on testing yielded a maximum accuracy of 93.11%.